since we're talking about the horizontal asymptotes and vertical asymptotes, okay, so let's try this question together, okay? Find the horizontal asymptote and vertical asymptote of this curve, okay? We're not going to check, well, if you can check separately, but we don't check it in class, okay? Now for this function, if similar question shows up in your exam, are you ready to do it? Find vertical asymptote, horizontal asymptote. Let's do the vertical asymptote at first. How to find a vertical asymptote?
So bottom half equals 0.
Yeah, okay, so to find the vertical asymptote, we let x squared plus x minus 2 equals 0. Let denominator equal 0. Solve for the x values. Let's factor. Does everybody know how to factor? Plus 2 minus 1. So it will give us x plus 2 equals 0, and then we'll have x equals what? Negative 2. X minus 1 equals 0 give us x equals what? 1. Okay? So x equals negative 2 as a vertical line, and x equals 1 as a vertical line are what? Our vertical asymptote. Okay? So later, when you are going to draw the picture of the curve, we know that x equals negative 2 is a vertical line, x equals positive 1 is a vertical line. We have two vertical asymptotes. Okay? How to find the vertical asymptotes? Let denominator equal 0, so for x values, then those vertical lines will be vertical asymptotes, right? How to find the horizontal asymptote? Find two limits, right? One limit is to find what? Limit when x goes to positive infinity, 2x squared plus x minus 1 over x squared plus x minus 2. Also, we're going to find what? The limit when x approaches to negative infinity, 2x squared plus x minus 1, x squared plus x minus 2. I will give you a couple minutes to try both of these two limits because we just practiced the very similar questions. Polynomial over polynomial.
I'll check it.
We don't have to factor out, right? Because we are finding the limit when x goes to infinity.
I thought I could make a shortcut.
Think about the previous question we just did, right?
I know.
What do? If you know the shortcut, both top and bottom have the same degree of x, right? So the horizontal asymptote for this function should be what?
2.
2 over 1. Right? Yeah, 2. You're right. Okay, so this limit is 2. Same thing here. X goes to negative infinity, 2. Or if you don't know the shortcut, what do? Divide by x squared from both top and the bottom, just like what we have did, and do it. It's kind of tedious, but you'll still get the same answer eventually.
Now you said some will have different negative and positive limits. Are we going to encounter any problems like that?
Well, it really depends. For this problem, both of the, when x goes to positive infinity and x goes to negative infinity give us the same value. Sometimes when you find the two limits, you may have two different values.
But how can they do that when the example formula is the same, the rules are the same? Like, even if it's 1 over x, and it goes to positive infinity, it's going to be 0, and 1 over x, it goes to negative infinity, it's going to be 0 too.
Yeah.
Why would it be different?
What do you mean why they're different?
Well, you say there's going to be sometimes when the two limits are different.
Yeah, sometimes.
But it says on the first page that n is a positive integer.
most of the, the two horizontal asymptote coincide with each other, I would say.
So would you say that's true for all rational functions?
No, it's not for all, for rational functions, yeah, I would say for all rational functions, they might have the same horizontal asymptotes. That means they still have two. One is when y equals 2, x goes to positive infinity. The other one is y equals 2 when x, approaches negative infinity. But they coincide.
That's what I'm saying.
Yeah, yes.
I can think of at least one case where they wouldn't coincide.
Yeah. There are some cases that they don't coincide. There are two.
As a rational function.
What case?
I'd have to just give me a few minutes on that.
Okay, so what we are going to do is just find two limits and sometimes overlap, and then we just say there's y equals 2 is the only horizontal asymptote for us. But sometimes I was showing you that indeed for some functions, okay, there are more than one horizontal asymptote. There are two because there are two limits. Sometimes the function goes this way, and then when x goes in that activity, it goes this. Okay, so it really depends. Okay, depends. So Graham is going to come up with some idea about whether they're hopefully, okay. And in the meantime, okay, let's move on. Okay, let's move on. Okay, so we're gonna go through this page. Okay, hopefully in 20 minutes. Okay, 20 minutes, 25 minutes. Definition. I'll talk about this. Limit f of x goes to infinity equals infinity. What does this limit if we can use a picture to describe it? Well, x goes to infinity, y goes to infinity, right? Right? And then this means y value will become large as x becomes large. Similarly are these following symbols, okay? So this is when x goes to negative infinity, y goes to infinity, right? Goes this direction, okay? This is when x goes to positive infinity, y goes to negative infinity, right? This is when x goes to negative infinity, y also goes to negative infinity. Okay? Yeah, so these are the, limits involving infinities. Okay? Now, this example, sketch the graph of the example of a function f that satisfies all of these given conditions. X goes to infinity, y approaches to 3. Oh, so that means y equals 3 is our horizontal asymptotes, right? X goes to infinity, y goes to 3. X goes to 2 from the negative. Okay, y goes to what? Y goes to infinity. X goes to 2 from the positive. Y goes to what? Negative infinity. F is an odd function. Well, I don't think we need to worry about that. Just draw briefly a picture, satisfy all of these conditions. You don't have to worry about that, okay? Infinity approaches 2 from the positive, y goes to negative infinity. How about this branch, see? X goes to infinity, y approaches 3. X goes to 2 from the positive, y goes to negative infinity. Does it satisfy these two conditions, right? It says, it's satisfied. How about x goes to 2 from the negative, from the left, y goes to infinity? And we don't know, okay? We don't know what's going to be happening here, but what we know is since y equals 3, well, we don't know what's going to happen on this side. What we know is when x approaches to 2 from the left, y goes to infinity. So our graph, we can stop it at here. Because it doesn't tell us when x goes to negative infinity, what will be our y goes to. So we don't know. So we just know, oh, when x goes to 2 from the left, y goes to infinity. So this picture satisfy all of the three conditions. That's okay. In your exams, I will give you some questions to give you some conditions. You have to draw briefly picture satisfy all of the conditions. Okay. But I don't think this is a hard question. No. Okay, now we have 3 practice questions. Find the limit. X goes to -3 from the left. X plus 2 divided by x plus 3. How about this limit? X goes to -3 from the left. If x goes to -3 from the left, x must be less than -3. Do you agree with me?
I have one.
Hold on one second. Let me finish this one.
Sorry.
Yeah. Okay, well, x approaches -3 from the left. X will be very close to -3, but less than -3, right? Now, I'm asking you, how about x plus 3 goes to? -3 plus 3, 0. But will this 0 be positive or negative? Negative, because x is less than -3, right? So I would say, on the bottom, x plus 3 approaches to 0, but less than 0.
My guess is 1. I don't know if I'm right.
Okay. On the top, when x approaches to -3, x plus 2 will approaches to where? -2 plus 3, -1. And then we say it's less than 1. Less than -1. Okay. Now we have a -1 over 0. What do you think? The entire fraction.
Positive?
-1 is negative, 0 negative is negative. So negative over negative will be positive.
Right.
So the result must be positive.
Yeah.
But if we have a constant divided by 0,
It won't exist.
it will not exist, just like you said. Positive infinity. It will be infinity because any constant divided by 0 will give us infinity, and then we have a negative over negative, that's going to be positive infinity. So correct?
X to the third plus x to the second plus 6x over x will give you, it'll give you two different limits.
Okay, so how about we talk about that in a later time?
Sure.
Okay, yeah. So that's good, everyone, for this question A. See, sometimes we may have the infinity as our limit. Not every time we get a specific number. Sometimes we have the infinity, yes. This limit, when t approaches to infinity, and this question will x goes to infinity. So these two questions, okay, we talk about when the x value or t value at infinity. How are we going to compute this? Any suggestion about the question B? This one is not a polynomial over polynomial, but what? Square root of t plus t squared, 2t minus t squared. Can we, so far we learned is what? Polynomial over polynomial, right? So can we consider it as a polynomial over polynomial? Yes, let's try it. Square root of t is t to the 1/2 power. So it is less than 2. So t squared, the 2 is a leading power, right? T squared is leading power. Okay, leading term with the highest power, 2, okay, exponent 2. On the bottom, negative t squared plus 2t, right? Because we can see that t squared, right? The square is also the leading one. Can you imagine what we can get? Both top and bottom have the same highest power, so the limit will be what? 1 over -1 give us what? -1. Or, if you're not comfortable with that, do it in detail. Divide by t squared from both top and bottom. T t squared plus square root of t divided by t squared, negative t squared plus 2t divided by t squared, and see whether we have the same answer or not. T approaches to infinity. What's t squared over t squared? 1. What is t square root of t divided by t squared? What is this? Oh. T to the 1/2 divided by t to the square. 1/2 minus 2, right? 3 over 2. Well, this is 1 over t to the what? 3 over 2. Okay? So I'm going to write it here, plus. Well, on the bottom, negative 1 plus what? 2t over t squared. 2 over what? 2 over t. Let's check the limit. Y is still 1. What is the limit when t approaches the infinity? 1 over t to the 3 over 2. 0. Negative 1. What's 2 over t when t goes to infinity? So eventually, what is 1 over negative 1? Negative 1. Do you see that? Or, oh, this is a polynomial with polynomial. We cannot say it's exactly polynomial, but square root of t is t to the 1/2 power. It is not, 1/2 is not as greater as 2, right? So t squared, negative t squared, so negative 1. Okay, so then it's what equals negative 1. The last question from the notes. X goes to infinity, square root of 9x squared plus x minus 3x. What is this? 9x squared, infinity, plus infinity, infinity. Square root of infinity goes to what? Infinity. How about 3x? Infinity minus infinity. Can we say 0? We don't know. Okay? Infinity minus infinity, we don't know. However, square root of 9x squared, 3x. When we encounter the radical expressions, think about the conjugate. What is the conjugate of this thing? Square root of 9x squared plus x plus what? 3x. Okay, so let's try this question in this way. From both top and bottom, this thing can be considered to be this thing divided by 1. We multiply from both top and the bottom what? The conjugate of this, which is square root of 9x squared plus x plus 3x and see what miracle result we can get. When the conjugate times by conjugate, when a pair of conjugate multiplied by each other, you remember what we have? A minus b times a plus b give us what? Do you still remember this formula? A squared minus b squared, remember? Okay, so what is a? The square root. What is b? 3x. So a minus b times a plus b will equals a squared. What is a squared? Square root of 9x squared plus x squared, right? Minus b squared. What is b? 3x squared. Well, on the bottom, we will still have square root of 9x squared plus x plus 3x. What does square root of square give us?
Just a function.
X plus x. What is 3x parentheses square? So, have here, everyone? 9x squared minus 9x squared cancel out. We have an x. You see that? On the bottom, we have a square root of 9x squared plus x plus 3x. What do we do next? What is the highest power from the bottom at this time? X, okay? Or you say, oh, 9x squared. But after square root of 9x squared, square root also give us x, right? So x is the highest, is a term with the highest power. So we divide by what? X from both top and the bottom. Okay, let me use another square paper to finish the question. Okay, so I'm going to write it here. Equals limit x goes to infinity. On the top, we only have x divided by x. 9x squared plus x plus 3x divided by x. So x over x is what? 1. We'll have a square root of 9x squared plus x over x plus what? What's 3x over x? 3. And can we continue to simplify this? Okay, I will rewrite it as 9x squared plus x divided by what? X squared. Why? Because x equals square root of x squared, right? And then plus 3. Under the square root, 9x squared plus x over x squared. What's 9x squared over x squared? 9. What is x over x squared? 1 over x plus 3. You got lost?
Well, I was copying it down, and then you went.
Okay.
When you're done, you go back over.
Okay, so when x goes to infinity, on the top we have 1. On the bottom we have what? 9 plus what? What's 1 over x when x goes to infinity? 0. Oh. So there's no limit anymore because there's no x anymore. So eventually we should have what? 1 over, what's square root of 9? 3 plus 3 is what? 6. It's a long question.
So does that demonstrate that there isn't a horizontal absent?